Atoms that are affected by magnets, two magnets are called paramagnetic, and those that are not are called diamagnetic. And the explanation for paramagnetism has to do with unpaired electrons. So anytime you have unpaired electrons, so that means atoms with partially filled subshells, you will have an atom that's paramagnetic. So to explain why nitrogen is paramagnetic. Here's nitrogen right here. It's in the P. So P1, P2, P3. So the valence configuration, the outermost configuration of nitrogen, is P3. It has unfilled, half-filled p subshell with three electrons. So those three electrons would spread out among the three orbitals, and they'll have parallel spins. So that's what makes nitrogen atom paramagnetic. Why are beryllium atoms not paramagnetic? Let's look at beryllium. Beryllium's over here. Okay, so what's the electron configuration for beryllium? Helium core, and then second row, that gives you 2s2. Okay, so your orbital diagram for beryllium, you have 1s, 2s, paired up in the 1s, paired up in the 2s. You have no unpaired electrons. Beryllium is not paramagnetic. So you can generalize this to say that all these atoms with an s2 valence configuration are not paramagnetic. And so anytime you have completely all the subshells, all the occupied subshells are completely filled, you have an atom that's not paramagnetic. Okay, so anything over here would be not paramagnetic. The noble gases will be further out here. Okay. The noble gases would also be not paramagnetic. So which of these is not paramagnetic? Sodium, magnesium, carbon, or titanium. You look at your valence configuration. This is P2, so that's 2 unpaired electrons in a p subshell. The valence configuration for sodium, obviously 11 electrons. One of them has to be unpaired, right? So this is neon core, 3s1. So you have that one unpaired electron in the 3s orbital. Titanium, okay, that's an argon core, 4s2, 3d2. Okay, that d2 is partially filled. If you remember, d orbitals can accommodate up to 10. So there's many different ways of distributing those two electrons in the d subshell. Okay, d subshell can accommodate up to 10 electrons. So that's also partially filled. So these are paramagnetic. So sodium's paramagnetic, carbon's paramagnetic, titanium's paramagnetic. The correct answer is magnesium. Okay, column 2A, and like I said, column 2B, or group 12, and the noble gases, those are your atoms that are not paramagnetic.